Hey everybody, this is Larry. This is day 26 of the June Leetcode Daily Challenge. Let's get started. Hit the like button, hit the subscribe button, join me on Discord, and I do this every day. Sum root to leaf numbers. Given a binary tree containing digits 0 to 9 only, each root to leaf path could represent a number. An example is the root to leaf path 1, 2, 3, which represents 1, 2, and 3. Find the total sum of all root to leaf numbers. A leaf is a node with no children. Okay. 40, is that 400 or 4? Okay, so it's 40. Okay, so I think the way that I'm going to approach this problem is just using depth first search or recursion. The case that I was looking for is just that making sure that, for example, I thought maybe they could do another digit if it, doesn't go all the way through. But in fact, we can just do all the sum of all the components. And don't have to worry about anything. So the only thing that you have to kind of keep track of is the current value. And then as long as you have that invariant of keeping track, you just keep on going until it is the children, then that should be okay. Okay, so let's just have a total is equal to 0. As a default. This is a little bit Python-y. You could write a helper function, but okay. So then now, what is my base case, right? Well, the base case is if root is none, we just return 0. If root.left is none and root.right is none, we return total plus root.value. And this is maybe total is a bad name. It's just like running sum, right? So this is at the leaf, we just return this value, right? Otherwise, we know that root.left is not none or root.right is not none. So we can just return, well, if root.left is not none, so we have a actual sum is equal to actual total is equal to 0. If root.left, we add it to the recursion, which is self.sum numbers, root.left, and then the current running sum times 10. If root.right is not none, then we do the same thing, but for the right side. And I'll explain this in a short minute. Let's see if this works first. And then at the very end, we return total. So let's also put in this other test case. But basically what I want to do is, well, that's not right. Oh, because I missed this. So otherwise, running some increment by root.value. Yeah. Critical miss, but yeah, is there a test case, edge cases? I guess like something like that maybe. Okay, cool. So let's submit it. Yeah, so let's go over this recursion real quick. So I did say at the beginning that it'll be depth first searched, and then the thing to notice about this is that as you go down, you kind of carry or you bring the digit with you, right? And what does it mean by bringing a digit with you? Well, you bring a digit with you when, for example, this is 1, it goes down, that 1 becomes a 10 on the 13, right? And similarly, the 1 goes down to 2, the 1 becomes a 10. So then just add it on. And then every time you go deeper, you multiply it by 10, which means that you shift it 1 digit. And then you add it to the current node's value so that it kind of puts it into the last digit, right? Yeah, so I think that's basically the idea to make it easy, because now you have about 10 lines of code, which is pretty straightforward. The only tricky part is going to be coming up with that. Otherwise, it's a depth first search, which is of course linear time, and you cannot do better than linear time because you have to look at each node at least once. In terms of space, we allocate memory on the stack, so it's going to be O of h, where h is the height of the tree, or O of n in the worst case. This is a very straightforward depth first search problem, so definitely practice it and have fun with it. In some other languages, you probably can't do a default parameter, so then you would have to create your own helper method, which is not that hard, but the same idea can apply, which is that this running sum shifts your input by 1 digit to the left, and then you just factor that into the current number, and then that's pretty much all you have to do. And then at the very least, you know, from all the numbers that you kept track of, you add it to the current number of the node. That's pretty much all I have for this problem. It seems pretty okay. Let me know what you think. Hit the like button, hit the subscribe button, and I will see y'all tomorrow. Bye bye.